What's up, everyone?
What's up, Climates?
Welcome to Planet of the Climates. Planet of the Climates is a community-organized podcast bringing you the latest information and insight into Klima. Klima is a blockchain protocol backed by carbon credits that gives people a chance to fight climate change as a collective and get rewarded for doing so. Klima sits at the intersection of blockchain, climate action, and the carbon credit market, so there's no shortage of great stuff for us to talk about. My name's Phaedrus, and I'll be your host on this adventure. I'll be joined by my good friends and co-hosts Reg and DiamondHands as we
discuss the latest Klima news,
drop some occasional alpha,
and connect you with the biggest and brightest names currently exploring this space. Unfortunately, Reg isn't able to join us, but I'm here with DiamondHands, and we're going to be chatting with Linwood Pendleton, who is Executive Director of the Ocean Knowledge Action Network and Future Earth. I'm sure you're going to hear all kinds of great stories from them. So enough from us. Let's just jump right into them. Okay, so Linwood Pendleton is an environmental economist, Executive Director of the Ocean Knowledge Action Network at Future Earth, and formerly the Senior Vice President for Science at the World Economic Forum's Center for the Fourth Industrial Revolution, as well as World Wildlife Fund Global Oceans lead scientist and chief economist at NOAA, amongst other prestigious roles. So thank you so much for taking the time to join us, Linwood. It truly is an honor. I'm sure our listeners will be eager to learn so much from you about so many different topics, but perhaps let's just back things up and have you tell us a little bit about yourself and maybe some of your earliest motivations for, exploring environmental economics and climate or ocean science.
Well, that really opens up a big can of worms because there's so many things that have pushed me in this direction. Really, I think the thing that pushed me into environmental economics was I was pursuing a PhD in ecology, working in the upper Amazon basin in Peru, where I studied black caiman. And if you don't know what a black caiman is, it's like an alligator. The biggest one ever caught was 8 meters long. The biggest one I ever caught was 5.5 meters long. And that was an important motivator for me to become an economist and not an ecologist. But when I was doing that work, the black caiman is one of the most endangered vertebrates in all of the Americas. And it's not because we don't understand the ecology. It's because we don't understand, or we didn't understand at the time, what was driving people to cut down the forest, what was driving people to kill black caimans. And so when I was confronted with that firsthand, living in the jungle, essentially in southeastern Peru, I realized that ecological knowledge in the world wasn't going to save this animal. I really needed to learn about people and about economics. And I left my PhD. I went and pursued a master's degree in environmental policy and economic development. And when I did that, I think, had my eyes open to the power of economics, not really as a predictive tool, but as a heuristic tool for understanding how people behave and how they use resources. And so ever since then, I've been looking at how ecological change affects people and affects them economically, how economic change drives people to do things that don't make good sense ecologically. And my love has always been the ocean. So no matter how many times I sort of drifted off into the tropical forests, I've always come back to the ocean. I did my PhD in part on the economics of coral reefs, and I had continued to work on issues mostly around wet and salty things.
That's a nice way to put it. But I'd like to dive a little bit deeper on this part, which really intrigues me a lot. What does an environmental economist do? Like, what actually is environmental economics in the layman's term?
Environmental economists can do quite a few things. Academic environmental economists may spend a lot of time trying to put a value on nature. And by put a value on nature, I mean really try to estimate how much does nature contribute to people's well-being, what kinds of resources should we commit to protecting the environment compared to putting that same resources into schools or roads or other things like that. There are environmental economists who spend quite a bit of time modeling behavior. And so they try to integrate ecological models with economic models. And I started off on a similar path, but over time, I realized that what was driving me was not the desire to be a really good academic environmental economist, but to be someone who was working directly in the conservation and management of nature with this lens that I bring to it as an environmental economist, but not restricted to that. So even though my PhD is in environmental economics, even though I was the chief economist of NOAA, a lot of what I've done is what we would think of now as being more transdisciplinary. So environmental economics is part of the way my brain thinks, but I've been trained as an ecologist. I've been trained in anthropology. And so I don't think of myself anymore as an environmental economist as much as I think of myself as a very pragmatic person who needs to harness technology, harness new ways of working with people in order to make sure that we're doing a better job of managing people and the planet. And I think this is what really has driven me into things like Web3, is it's just a new way of organizing people, a new way of thinking about linking economic outcomes and incentives to things like the blockchain. So I've migrated into Web3, I think.
Wow. Yeah, we definitely want to get there. Yeah, being representing Klima and talking about a major blockchain Web3 project here, definitely want to get there. But let's just when you're talking about putting that value on nature, you're doing that because why didn't we value nature? How did we get to that place where we didn't?
Yeah, and if you go back to the very earliest days of environmental economics, the idea there was that people were doing benefit cost analysis of everything. And in fact, it became the law in the United States that every new project that was going to be funded by the US government had to first conduct a benefit cost analysis. And the environment never appears in those kinds of benefit cost analysis. And so we were really trying to understand, well, how can we reflect the economic importance of, say, a park or clean air or clean water in these cost-benefit analysis. And so that's where we really tried to start to put a value on nature, so to speak, just so it was represented in that benefit cost analysis. As we started doing that, though, we realized that, well, as we understand this, we start to see why people have incentives to do bad things. And maybe we can use this thinking to address those incentives, or maybe we can create new incentives for them to do good things. And I think that really is the power of economics generally, is integrating it into our thinking, because the world is really complicated. And if you try to understand that complication in all of its glory, it's very hard to know where to start. So for me, economics was initially a way of simplifying the role of nature in people's lives, and then putting that in the context of something like a benefit cost analysis, but then putting that in the context of public policy, and then thinking about that from the perspective of conservation. You can appeal to people's hearts when you try to get them to protect nature, but there's a lot about nature that people just don't understand or does not appeal to their heart. So when we talk about a panda or a whale, that makes people sort of happy inside. If you talk about the carbon cycle that's associated with a whale or krill or a mangrove, then you just get a blank stare. It's not necessarily appealing to their heartstrings. But if you then begin to say, well, if you protect a hectare of mangroves, that could keep 1,000 tons of carbon in the soil beneath the mangrove. And that's the equivalent to all the carbon you produce in a year. Now people start getting it, but they get it because you're making an economic argument for the value of a mangrove.
So much of what we do and value and believe in and take action on has been framed up by our economic systems then. So is this again where that word externality comes from, that like so much of nature and the environment and our atmosphere and our oceans has been kind of externalized in traditional economic thinking? Is that right?
Well, yeah. And when we originally start thinking about externalities, it was what are the unaccounted for negative impacts of our actions that happen externally. We did a much less good job, so a worse job, in thinking about the external benefits that nature provides to us. And when you think about the government giving a tax breaks to people or sending a stimulus check to them, you could take that money and invest it in nature, and it would be like giving people the same amount of money, but in perpetuity. And it's shared because it's a public good. So really, the way we think about nature, it's gone through, I think, many evolutions, and we're continuing to think about how nature affects our well-being. I think in some senses, environmental economics has gotten stuck because I think a lot of people hoped that as soon as we showed people the economic value of nature, it would fix everything. But a lot of people then look at the economic value of nature and say, well, look, I could do without a little bit of that. And then what we have to do is go back and say, okay, well, look, it's not really like a basket of fruit where you can just pull out the apple and the rest of the basket's still there. It's all connected. And this is where in environmental economics, it becomes a limiting way of thinking about nature, and that we don't do a very good job in terms of understanding what is the value of the resilience that comes from having all these parts of nature there at once. And so this has led us to focus on certain parts of nature that are easy to quantify, that have a demonstrated market value at the expense of other parts of nature that are equally important, but are hard to describe, hard to quantify, and hard to really understand how they contribute to this basket of goods that we call nature.
Yeah, this is a question that I would like to ask, as you actually explained earlier on as well. I personally think, over the last probably 10 years or so, this narrative of, being carbon neutral, carbon positive has been on the rise itself. What do you think contribute to that happening? Is it because of the rise of Web3, the rise of vast free knowledge on the internet, or?
I think the possibility of offsetting your carbon without actually changing what you do got us moving down that path. And then people realized that carbon offsets aren't that expensive. I could offset all of my carbon and be carbon neutral. That would be easy. And I don't have to really change what I do. Now that I've done that, now maybe I can actually start taking some steps in the way I work and become carbon positive even. And so it became a tractable way of addressing what seemed to be an intractable problem, which is climate change. So I think that's what led us to start thinking about being carbon neutral and then ultimately carbon positive, which is once we were able to offset our carbon, we could get to carbon neutrality pretty quickly. Once we were able to go beyond just our carbon footprint by offsetting plus, we could become carbon positive. And then once we could start doing things like replacing dirty energy with clean energy, it just kept getting easier and easier for us to think about. Where we stopped is, well, are there any potential negative outcomes of this pursuit to be climate neutral or climate positive? Are we looking for magic bullets, particularly in nature? And if we are, how is that affecting the other parts of nature? So I have referred to this sort of fruit basket mental model for nature. If all we're doing is focusing on climate, are we doing things that also benefit biodiversity? And are we doing things that benefit resilience? And are we doing things that benefit local people who depend on nature? And it's not necessarily the case that what's good for carbon is good for biodiversity, is good for people, etc.
From what I'm hearing, there's a lot of thought involved when it comes to being carbon neutral. You have to also weigh in the pros and cons of what you're doing to be carbon neutral, and in turn also or even being carbon positive, right?
Yes. We can't sort of look carefully at the carbon footprint of some parts of our lives and ignore the carbon footprint of other parts of our lives. And that I think is really tricky. So we end up feeling good about ourselves in the parts of our lives where we can be carbon neutral or carbon positive. Meanwhile, we're doing terrible things in the other parts of our lives. It could completely offset all that good that we've just achieved.
Yeah. We did have an earlier conversation with Chad Frischman from Project Drawdown talking about just all those different ways they're connected to in terms of the solutions. So definitely, not wanting to think of things in a unidimensional or, hey, I offset my car or I offset my meal, so that's good, done. Now here, you've authored several articles kind of illustrating the connection between atmospheric greenhouse gases and, the health of marine ecosystems. I think a lot of us think, just about those greenhouse gases, like just what we're emitting or that flight I took or that vacation I took. What's the main thing that you would hope people understand or they really grasp about that connection between those emissions and the species and environments that, might be remote or small or unimportant in their minds?
I think the most important thing to realize is that it's not something that can be easily undone. So even if you stop emitting carbon today, climate change is still going to happen. The ocean is still becoming more acidic because there's just so much carbon dioxide in the air right now. And that has led us to really think about how do we get this carbon dioxide out of the air, because we know that even if we do everything right now in terms of lowering our carbon footprint, it's going to be a really bumpy future. And we're going to lose a lot of coral, and we're going to lose a lot of marine species, and we're going to lose a lot of terrestrial biodiversity, et cetera. So it's not enough to be carbon neutral, and it's not even enough to be a little bit carbon positive. We have to turn back the clock somehow. At the same time, we cannot panic and employ techniques to turn back the clock that could end up having the same negative effects on biodiversity. And this, I think, is really the tricky balance.
So you're talking about things there like geoengineering or throwing iron into the oceans or what? I don't know what all the different technologies or things that are floated around there.
That's right. I mean, and there's sinking carbon to the bottom of the ocean. All of these things are worth thinking about, but we have to be really holistic in the way we think about this. And we have this tendency now to search for silver bullets, and we want to find the one ocean bacterium or the one ecosystem or the one new technology that's going to suck gigatons and gigatons of carbon out of the atmosphere. And I don't think it's practical, one, because the probability of finding that kind of technology or that solution is pretty small. Number two, the possibility of having unintended or perverse outcomes is pretty high when you think of something that has that amount of carbon that you're taking out of the atmosphere. You have to put it someplace. So we have to make sure that we use science, we use the precautionary principle, we are careful about how we take carbon out of the atmosphere, we monitor its effects, and only then do we scale up rapidly. We have to scale up rapidly, that's for sure. But it won't do us any good to start at scale that works for carbon and then doesn't work for nature, because one of the whole reasons for getting carbon out of the atmosphere is to protect nature. So we've got to keep both in mind.
Yep. Based on our research, you've done a lot of work around what is termed as the fourth industrial revolution. Of course, I'm no expert, but based on my research, it means digitalization and automation itself. Speaking of that, this fourth industrial revolution, could it be addressing some of the bigger challenges we are facing now when it comes to be carbon neutral or even like carbon positive?
Well, I think if you reframe that to say, can it help us address the challenges of managing this planet that has a very thin layer of biological activity on it and a very thick layer of atmosphere? It's key. And when I really started getting into this, it was because it was clear to me that we had a data problem that was affecting our ability to understand the ocean and therefore the planet. And that data problem included our inability to get the most information and the most knowledge and understanding out of all the data we have out there. But the other data problem was that we don't have data for the whole world when it comes to the ocean, when it comes to the atmosphere, when it comes to people. There's still really big gaps. So I started wondering how the fourth industrial revolution, and thinking particularly of artificial intelligence, data interoperability, the Internet of Things, and blockchain could start to address some of those problems around data. And that really is when I started getting into this fourth industrial revolution, thinking about this. I published a paper a couple of years ago with colleagues from the World Wildlife Fund and colleagues from IBM called Disrupting Data Sharing for a Healthier Ocean. And that really is where we looked at this fourth industrial revolution. We weren't calling it that at the time. We were still using, I think, very kind of old school IBM terms. We tried to dance around blockchain because even 2 or 3 years ago, if you said blockchain to scientists, you got an eye roll and then a blank stare. So we went way out of our way to talk about distributed ledgers. But we're really making the point that we have a lot of data. And if you're still using old school methods to analyze these big sets of data, you're just building your biases in. There's a lot we don't understand about the planet that AI can help us understand through unsupervised machine learning. There are incentives that we could try to create to get people to collect data, because more and more people aren't collecting data because the incentives we give scientists are built around publishing. And if you want to publish, why waste a lot of time collecting data when you could write a paper about previous papers that have been written? And we'll call that a review paper or maybe a meta-analysis. But that's because we can quantify papers published and who cites those papers. But we can't quantify who uses your data and how impactful your data is. So there's no data impact factor. So there's no way of giving people rewards for producing important data. And as a result, we see less and less data being created. We see less data being shared. And so this just sort of, all of this gets back into this fourth industrial revolution. We have to understand that and see what are the options for using those 4IR technologies to solve some of these problems that we already know that we have in science, in conservation, and sustainable planning.
Wow. You just open up so many other little ideas there too. Like you're just kind of referencing this fact that academia itself needs a whole new economy as well too, right? Or a new, system of valuing what knowledge is produced, how it's produced and shared.
Yeah, and what counts as knowledge.
Yes.
You also mentioned about blockchain itself, right? So you were saying like 2 years ago, scientists were looking at blockchain will be like giving a blank stare. How do you see blockchain? How does it help to address those issues we're talking about in terms of like data sets, huge data dumps and stuff like that?
If you just think about blockchain itself, I think it has an immediate connection to data in that it is a way of giving the data producer some ownership of the data while still allowing them to share those data open and freely. So for me, that always has been the biggest problem, because scientists have hoarded their data. They've kept it until they've gotten as many publications as they thought they could get, and then they've released it. And that's a problem. And they do that because they feel like, well, once my data are out there, then anyone can use the data and I'll never get credit for it. So if you start creating a blockchain that creates a digital deed for the data you've created, you can know who uses your data and you can get credit for that. And not only can you get credit for it, but you can do a better job of producing data if you know how it's going to be used. So for me, that's kind of the immediate way of thinking about this. But the other thing we're seeing is that a lot of countries now have awakened to the fact that data is a resource with value. And they don't want to share their environmental data, because why should Ghana let the world have its ocean data if that's just going to be used by a fishing fleet from a different country or an oil and gas company? And then this gets even more complicated when we start thinking about indigenous knowledge and who owns the rights to the genetic knowledge that is incorporated in discovering a new species. So I really see blockchain as being a potential solution to that intellectual property issue that has kept us from sharing data. But then once we have that blockchain that's associated with data, then we can start rewarding people through data impact factors, but we could even start paying people for their data. And this is where NFTs, I think, come in. So NFT, of course, is built on a blockchain, but we can reward people if we could create an NFT for the set of data that they've provided. And I see that as sort of the very low-hanging fruit. I think where I get most excited, though, from a very practical perspective, is that I was part of the team that worked on designing something called the UN Decade of Ocean Sciences for Sustainable Development. And it really is an effort to get marine scientists everywhere on the planet to rethink how we do marine science so that we work with stakeholders, so we understand the decisions that they're trying to make, and we give them the data they need. And now that we've done that, we have thousands of people all around the world who have raised their hands and said, we want to do this. We're ready to collect data, but they don't have the funding to do it. And so this is where smart contracts and what my colleague Bryce Gurk and I have been calling decentralized conservation, where it's like decentralized finance, where you can use smart contracts and the blockchain to really take the intermediary out of the way we collect and distribute funding for science and replace it with a more automated approach so that we can give away lots of small amounts of money to really encourage people to start doing science and collecting data, even in those places where previously it was hard to get the money, or if we did send money there, it was hard to verify the impact of the projects, that they did what they said. And it's because we have focused on centralized ways of giving away money that we tend to give money away in very big chunks. And that means it goes to big consortiums in the developed world, and it doesn't get distributed to these small players, small scale scientists who are everywhere, but can't do their science because they don't have funds.
That's just awesome. I think, when we were initially asking these questions about, what do you think about blockchain? What do you think about Web3? In a sense, we're, at least I'm thinking like, let's talk about, carbon credits on chain. And I'm sure we'll get there. But just what you've illustrated is this vast potential for, decentralizing and democratizing climate science itself. Do you have any illustrations? Are there any projects that are actually doing what you're describing right now?
There are a lot of projects that are in the works now, these conservation DAOs. And some of them aren't DAOs, but many of them are trying to decentralize at least part of the funding stream. And sometimes it's science that's the recipient of this, sometimes it's conservation actions. And so Moon Jelly is an organization that's got together that's thinking both about how do you distribute money in a decentralized way to ocean conservation and ocean science. Rebalancing Earth is doing this. There are a number of organizations. Most of them now are either focused on how do you raise money in a kind of a decentralized way, and they're really focused on NFTs. Some are focused on how do you find recipients and get the money to recipients, no matter where the money comes from. And then some of them are trying to put the whole picture together. But at this point, it's still early days, and it's a bit of the Wild West. And this is where my work most recently has come together, which is we at the Ocean Knowledge Action Network have worked with Moon Jelly to create an independent 501c3 in the US, which is a nonprofit, to try to get scientists involved in creating some basic guidance for these DAOs and these Web3 initiatives that are now coming together and promising big things for the way we do ocean science and fund ocean science, and do ocean conservation and fund ocean conservation. Because it's easy for these things to go wrong if we don't involve the scientists.
Yes, for sure. So that's very cool. Thank you for that illustration of this kind of, emerging blockchain Web3 ecosystem that is, developing a new way of doing science, funding the science, sharing it. And again, like for us at Klima, or, with other protocols that are working with tokenized carbon credits, and, we're trying to find new ways of, financing these solutions. So we're kind of, positioning ourselves, or we've had that umbrella phrase that's out there a little bit around refi or regenerative finance. Do you see like refi as being a suitable umbrella term? Does that capture what you're talking about too? Or is there another word for that?
I think there's only part of refi. So to the degree that refi is built on DeFi, that is a sustainable way of raising money for this kind of decentralized conservation or decentralized science funding. But you don't need refi to do decentralized conservation funding. You could, for instance, do it through charitable donations. And it all depends on how decentralized you want to be. So if you imagine that there are philanthropists with huge amounts of money, like Mackenzie Scott, that have to give away their money in $40 million chunks because it's too costly to give it away in small pots. Well, the decentralized half of what I've described, which is just how could you give money away to lots and lots of small projects that deserve it, that could still work with that kind of philanthropic money. You could sell one NFT for 10 million euros and then give that away in a decentralized way. And so, well, there's a sort of fractionalizing an NFT where people own a fraction of the NFT. But even if you just say, we sold this NFT to one rich whale and they gave us $1 billion, you still have to spend that to make an impact. And can you spend that in a decentralized way? So we talk about the decentralization of conservation, but it really is, there are many aspects of this supply chain of money. And really what we're talking about is the supply chain from someone has money to someone who needs money that can be decentralized. It could be decentralizing the contributors and finding ways of bringing lots of small contributors on board. It could be decentralizing the decisions about who should get money and what we should spend it on. And that's where I think DAOs are really promising, because that's a good way of decentralizing those decisions. And you could talk about decentralizing who gets the money in the end. And so right now, it's difficult to try to solve all three of those problems at once. And I see these different Web3 initiatives focusing on different parts of that supply chain. Each step along the way, there are perils from a scientific perspective, from a diversity, equity, and inclusiveness perspective, from the probability or possibility of creating a system that leads to colonial conservation or colonial type science that we want to avoid. And this is where at Moon Jelly Academy, we're really trying to get the scientists involved now. So we can say, okay, well, if you're going to do this, you need to keep this in mind in order to have a positive outcome. If you create your DAO and everybody in the DAO who gets to vote is living in a first world country, but all of the money is going to a third world country, then that's very colonialistic, because what you have is people in one part of the world influencing what people in another part of the world do with their money. So how do you create a governance system in the DAO? How do you get people who are in these countries that are going to receive this money into the DAO so they can participate in decision making? So these are the kinds of things that I think we need to address early to make sure that getting Web3 involved in the funding of science and conservation leads to positive outcomes and doesn't just repeat all the bad things that we know we've done in the past 50 to 100 years that have left us with this planet in decline.
Yeah. How about carbon credits and the carbon markets where, as KlimaDAO itself, we are trying to build the carbon market on chain. What do you see in terms of the vision of KlimaDAO?
Everyone around the world working in conservation recognizes this need to be holistic. They recognize the need to have verifiable impact. But what that has done is that it has pushed us to funding bigger and bigger projects, because you have to have a big project to have a discernible impact on nature. You have to have a big project in order to account for all these dimensions that we've just discussed. And that's why a lot of these carbon projects, if you talk about blue carbon projects, that the minimum viable size for a blue carbon mangrove project now that's going to get a carbon offset through Verra is something like 20,000 hectares, because that's how big it has to be in order to pay for all of the costs of carbon verification, all of the costs for getting the carbon scientists there, all of the cost for working with the community, et cetera. So in a sense, we've made this search for the perfect, it has become the enemy of the good, which means there are a lot of small projects out there that are no longer getting funded because it's very difficult for them to show impact, or it's very difficult for them to deal with all of these different dimensions and factors because they just don't have the expertise to do it. And, you take that one step further, we talk about trying to do things from ridge, the top of the mountain, to the reef. And that can be a huge area. And so once again, that requires a really big project. So I think one of the things that really draws me to this idea of decentralized conservation and decentralized science impact is that we should be able to create incentives so that when small projects work together, they can demonstrate that they've had a result, even if it's not what we think of as impact. That is, they can't 100% show how they've affected nature. And instead of them having to be entirely holistic, if they're working with other projects nearby and coordinating, can we create incentives, an additional incentive for that kind of holistic coordination? So the whole is greater than the sum of the parts kind of thing. And I think Web3 will get us there. I think the blockchain can get us there, and it can help us reverse this course that we've taken where people only want to fund these big, giant projects, because the people who can really make a difference, I think, in protecting the planet are often working at very small scales. And that's because the problem is different from bay to bay and from community to community.
Yes. You talked when you're, illustrating your career and your background there too, with this black caiman species that you were researching and studying as well too. When you're talking now about, bringing it back down to the community level, bringing it back down to a local level, what's a story or something that you would use now or that resonates so much with you now, a species, a place, an ecosystem, something that really resonates with you that you think people would pick up on if they understood better?
Well, I have a friend who, a PhD marine scientist working in Ghana, and he has created a way of collecting data about sea temperature that is absolutely critical to understanding where the fish are and where they're going to be and how this is changing. He has a little device that is simply a device that you can get on the market. It's called the CTD. It measures temperature, salinity, and things like that. And the device can be attached to the canoes that these fishermen use, and it could collect data that is incredibly important for those fishermen, for the people who manage that fishery. But it would also provide data for our global ocean and climate models that is completely missing now. But he doesn't have a source of funding for this, and he doesn't need a lot of money. And so it was in talking to him that really sent me down this rabbit hole of decentralized finance. Because I said, well, for every person that is like you, I could give you $10,000. You could collect this information, or I could wait until a research cruise or a satellite or something that costs a lot more money finally gets sent your way. And why can't we somehow create a market for you where you're not selling the data, but people are paying you to collect data that has global value and that can be collected by you in a way that would be much cheaper than if we just wait for Northern Hemisphere scientists to come down and collect it for you.
It can be so much more nimble.
And one of the things that's kept people from sharing and collecting that kind of data in the first place is they said, well, you just want us to collect these data so you can go off and use it in your science in Europe or your climate model that really isn't going to shed light on what's happening. If they're deciding what data they want to collect and then putting that on the market, that really is bottom up. And I think that's where we need to be right now, because if we want people to take sustainable action at the local scale in West Africa, in Papua New Guinea, in Ecuador, the data and science there has to be meaningful locally. And there just aren't the resources for paying for that data and science right now, because you've got a pandemic, you've got poverty, you've got schools that are failing. So we have to recognize that we can create a more science-informed planet by giving people resources to create a more science-informed local ecosystem or community.
Excellent. That really is that bottom up or roots up or grassroots approach then.
Yeah. So there's this question that we ask all our guests, and this question is called the 2033 question. So for this case, the question is, you work with Future Earth. As I can see, it's actually a global network of scientists, researchers, and innovators, right, to collaborate for a more sustainable planet. And my question is, where do you see the future of blockchain and the fight against climate will be in 2033?
Well, I see it in many places. And one of the things that led me to start thinking about DAOs was, could we do a better job of networking all of these scientists in Future Earth through a DAO rather than the way we do it now? And one of the things that we've seen with the UN Decade for Ocean Science is we've got thousands and thousands of people, and they're not connecting to each other. They don't know how to collaborate at large scale. And so I really see the blockchain helping us do that through DAOs. So that's one thing. The second thing is, as I've mentioned over and over again, it's not just the scale of funding that matters. And it's great when you get all of these governments promising hundreds of millions of euros to fund ocean science. The thing that is going to make a difference, and I hope in 2033, is that this money is going to more people with more ideas, because it's going to take thousands and thousands of new ideas and thousands of new sets of data in order for us to have the information we need to do a better job of managing the climate. And until we do that, we're not going to tackle climate change by having a handful of organizations compete for global prizes and awarding one prize to the winner and a couple of runners-up. We need hundreds of thousands of winners who have new ideas, new ways to collect data. And then we need to provide incentives so they're sharing those data, because ultimately you can't manage the ocean unless people are sharing the data, because it's just one ocean. You can't manage the climate unless people are sharing data. So I really hope that by 2033, we're giving money away in a completely different way. We've revolutionized the incentives for sharing data and sharing technology, and that we can then use all of these data and new science projects to create a more informed planet.
Yeah, beautiful. Great to hear that. We've been talking about, carbon getting to, carbon neutral, carbon negative, and ultimately rewinding the clock on more than a few decades, but perhaps a couple of centuries of carbon that's been thrown up into the atmosphere or more here. So it sounds like with that vision and what you're illustrating for 2033, with that re-incentivized or realigned finance for these solutions there, it's doable. I guess that's the bottom line. It's doable in your mind?
It's doable. And even if we can't turn the clock back as far as we want, you still need the science and information to help people adapt. And I think that's crucial. You can't turn the world backwards because people are living in places that they didn't live 100 years ago. Species have already moved, and it may be difficult for them to move back. So no matter what happens from a climate perspective, we will be in a better place if we have more information and understanding of the way the planet works. And so that really is where I'm very positive. Even if the politics, even if human behavior is difficult to overcome, we can do better. And I think ultimately that is sort of the limits of my vision, which I still think is fully feasible by 2033.
That's awesome. That's great. I think that really puts a ribbon on our conversation here. We've definitely exhausted our notes, what we were hoping to chat with you about.
Yeah, totally.
Good. Well, it was fun.
Thank you very
Thanks,
much.
Linwood. Really appreciate it.
Thank you. Bye-bye.
Excellent. What an awesome conversation. I thought it was just so great to meet and chat with Linwood and learn more about his story, his background. So I don't know about you, DiamondHands, but for me, a thing that really resonated with me was that initial story that he was talking about, working with the black caiman species, and then that shift or that pivot that he had, saying something's wrong when we're not really accounting for how or why this species is actually going extinct and threatened. That pivot towards ecological economics or environmental economics that really recenters the world around us and puts value on it. And then I just thought it was so awesome that we got schooled on that stuff and eventually came to talk about, Web3 and the solutions that are available to us now. What really resonated with you?
I think it's how scientists, not just when it comes to Web3 itself, we generally associate with degens, people who are here to invest, but we never really look at the other side of the spectrum, whereby they are all scientists and using that collaborative spirit of Web3 to share data and share information to build a more robust system for us to really not just justify, but build up better systems or better technology that's going to help us fight climate change. I think this is something that's really, really interesting to see how Linwood himself thinks of both sides of the equations, in the sense where yes, we are being carbon neutral, we are being carbon positive, but what are we doing any form of biodiversity by doing that at the same time? So I think that's really some deep thoughts that we're gonna have on our own to see how can we do something that is positive on both ends.
Yeah, I really appreciated that feedback, and that Linwood's kind of always looking for those unintended or unanticipated outcomes, impacts, and maybe some blind spots in terms of you're pursuing a solution and it's not just the one solution while you're overlooking or ignoring other solutions too. like we're always thinking about ourselves in terms of, DeFi and refi, and just what you alluded to there, that potential for Web3 to really revolutionize climate science. And I don't know if that's DeSci, if that's the hashtag or not, but I think it's just what's possible there in terms of how science gets funded and carried out and disseminated and all that. It's just very cool. I hope you enjoyed this conversation too. For everything Klima, make sure you're hitting up KlimaDAO.finance, our one and only home on the web, and where you can find information to stake, bond, and I think most importantly, check out the resources and our community tab there that'll hook you up with our Discord community. Because we're a decentralized, autonomous organization, Klima is community-driven just like this podcast, so get connected to our Discord and you'll find a great group of Climates and plenty of opportunities to contribute and be an active Climate too. So we hope you really enjoyed this conversation with Linwood. Thanks so much for joining us, and we're looking forward to saying hello once again on the very next Planet of the Climates.